most powerful rocket to have ever flown as August 2024, the biggest, most powerful rocket capable of carrying up to 100 people on long-duration mission, interplanetary ones, fly in deep space. Today we talk about SpaceX Starship and how it works. Welcome back on the SpaceInfo podcast. Here we talk about space and everything related to it. If you are passionate about space, astronomy, technology and everything about it, you can join all our social platforms at the SpaceInfo Club or our website at www.spaceinfo.club, where tons of content and a community of experts are there waiting for you. This is the SpaceInfo Club. Thanks for being here. First of all, thank you for joining the SpaceInfo Club podcast. If you are new to the podcast or you are watching on YouTube or listening to the SpaceInfo podcast on the audio streaming platform like Spotify, thanks for being here. Consider subscribing and joining the club on our website. Share us with your friends. It's completely free, but gives us a huge hand in growing and giving you 100% free content and keeping working on what we love the most, which is space. Today we talk about SpaceX Starship and how does it work. So it is the biggest and most powerful rocket to have ever flown as of July and August 2024. We are recording in August 2024. Just give you a few details before entering into the official presentation of the vehicle. It is 120 meters tall, something like a little less of 400 feet, with a diameter at the base of 9 meters, which is about 30 feet, an incredible mass of 5,000 tons, which is something like 11 million pounds. And SpaceX Starship is the most powerful launch system ever developed up to now so far. Starship will be able to carry up to 100 people on long duration interplanetary flights. And we will talk about this later, about how much people can carry into low Earth orbit or moon missions, for example, in the future. Starship will also help enable satellite delivery, the development of a moon base, and also SpaceX says point-to-point transport here on Earth. Well, this last topic before officially introducing the vehicle, what do we mean with point-to-point transportation? Well, this is quite a peculiar characteristic of a rocket system, because SpaceX not only envisages spaceflight as a flight outside the atmosphere towards the moon, towards deep space or Mars, but also lowering the times, the traveling times between two different locations, both situated on our planet, by using rockets. Basically, let's start talking about the spacecraft. As I said, Starship is a massive spacecraft and rocket system developed by SpaceX, because I say the spacecraft and also rocket system because SpaceX is developing both the spacecraft and also the Super Heavy booster. We usually refer as a Starship to the spacecraft, but also to the full configuration of spacecraft itself and also the booster, because they are on what could be said as a tandem configuration. So they are basically one on top of the other at the launch configuration, and then they detach one with respect to the other, and the spacecraft keeps flying into the Earth atmosphere. At least that's what it performed so far, what we have seen, also thanks to Starlink, another I would say very peculiar project by SpaceX. And then the Super Heavy booster, as we have seen for the boosters of the Falcon 9 rocket, is capable of landing by itself back on Earth. You can see, if you're watching us on YouTube, the fins, the control fins, which allow an aerodynamic control of the booster itself, which is also capable of thrust vectoring its thrust, which means if you are outside of this world, that you can control the thrust that's come from your engine, and you can just give directions, orient the force vectoring of the booster in order to keep it in balance, and also by lowering little by little that force you can just perform a very smooth landing in the vertical configuration. So which are the key features of this spacecraft? Well, together they stand at an impressive height of 120 meters, making it the tallest rocket ever built. Well, I decided to give this feature as the very first, just to give you an idea of how big this rocket is. Actually, it is even bigger than the Saturn V. We'll see then in a few seconds the comparison, but it is very important to understand this because it is a very important feature also in the economical scale under the overall project, and why it can be so revolutionary under the also business point of view. So the mission of the spacecraft is basically to make Starship capable of performing different missions, also including lunar landings, and then eventually also being the enabler for Mars exploration, at least in the vision of Elon Musk. But for what they are doing, how they are doing, probably this is the most I would say the favorite vehicle for a mission of that kind in the future. So the purpose of the whole project, in particular the Starship spacecraft, is being designed to carry both cargo and humans. Indeed, if you have followed the overall project, the overall launches, the test flights, you maybe have seen some images of the internal cameras of the Starship spacecraft while in orbit. I think that was a couple of test flights ago, or one test flight ago, when they performed an almost orbital insertion, and during this phase of the flight they tried to perform an opening of the cargo hatch and then closing it again, which was not 100% successful, but this gives an idea of also how big it is. Also, if you go and look the images, you can see the quantity of free cargo space that is inside the cargo version of the Starship. Actually, this is a prototype. That was a prototype, so it was not configured as a fully cargo spacecraft. And in all that hollow space, you can also fit in an hybrid configuration, a full, I would say, human configuration to put astronauts and crew and also passenger on board. And then you can also fit in cargo and things like that. But this gives you an idea of how much space you have at your disposal. Basically, for how big it is, you may now wondering. I want to remember the mass of the spacecraft, which in the full configuration, so Starship spacecraft and also the Heavy booster, well, the overall mass is something like 5,000 tons. So this is huge. And for sure you need a lot of propellant, a very efficient and I would say also complex propellant system in order to propel the rocket and thrust it into the atmosphere outside of it, and also making it capable of space flight. Well, I would just give you an idea about this last topic by saying that the spacecraft has a propellant capacity of 1,200 tons and can transport up to 100-150 tons of payload. Well, when I say the spacecraft, I only mean the Starship spacecraft, so the top spacecraft, which is placed again on top of the Super Heavy booster. So this just to give you an idea of how big it is. Well, and also I would like you to think about the percentage of the mass distribution. You have to think that this is not far from the common percentages we are used in rocket science. Indeed, you have something like 1,200 tons of propellant, and then around 10% of this mass. So you have to add again up to this between 100 and 150 tons dedicated to payload. There are for sure, let's say, approximated numbers, but just to give you an idea of how rocket science works. This is not something which is completely dependent on the system you're using. So people flying the Saturn V 60 years ago had to make the counts with the physics, and the same thing is here. So if you're passionate about this, you can find some information on our website and also inside our little courses that we are going to release, and also one rocketry course is also released, so give a look in our website. But this is basically a matter of rocket equation. So if you are familiar with this, you will find out that these percentages are quite common and they are due to the physics. So there is not much that you can do about this. So 10% is dedicated to the payload, something like that, and 1,200 tons, that's the third time I'm saying this, but is very impressive, are dedicated to payload. And I'm saying that this is very impressive because I would like you to think about the overall mass of the full configuration rocket, and now think about the whole propellant which is inside the full system. If we also consider the Super Heavy booster, well, the Super Heavy booster is even larger, with the propellant capacity of something like 3,400 tons. So if you think that the overall mass is around 5,000 tons, and 3,400 plus 1,500 is a huge amount of of propellant, which is used to put into orbit or to inject into deep space, interplanetary mission, also missions to the moon. A relatively small payload, which is something around 100 tons of kilograms, 100 tons for sure. Well, this is physics, as I was saying, but just think about the amount of propellant which is dedicated to such a relatively small amount of payload. Again, if you're curious about this, comment down below. Let me know if you want us to go deeper into detail about how rocketry works, just the principles of the physics behind it. Just let us know, let me know in the comments, and I will make some content about this for sure. So if we go on, as I was saying at the beginning, we could also compare the spacecraft fully configured, so spacecraft plus EV booster, so the full Starship, and the Saturn V rocket, one of the most iconic rockets in history, the one that helped people and American astronauts to go on the moon. So this massive propellant capacity also makes Starship the most powerful rocket ever built, capable of generating twice the thrust of the Saturn V rocket. So Starship is not double the size of the Saturn V for sure, but the propellant combination is a little different. For sure, engines are different, efficiency of this engine is different, and also the technology is almost, I would say, well, quite completely different. But I would like to just to give you a few mentions about the structural conception of spacecraft of the Starship, and you know that it is not as revolutionary as you may think. And while I'm talking, I would just challenge you to stop the video or just comment down below why I'm talking, why the structure of the spacecraft is something like steel and not carbon fiber or some, I would say, so high technology material, far from the almost common aerospace steel that you'll see in the majority of the structure of the spacecraft. Well, if you accept the challenge, try to write down below in the comments. Now I'm going to tell you why. Well, you have to think about the principles behind the business case of the spacecraft. Well, don't forget that SpaceX is a private company. It has to make profit, and the idea behind the company itself is not the scientific research. It's not demonstrating that they can build a rocket and fly it into space, and then end of the game, Elon Musk is happy, every fan is happy, and they say, okay, we are capable of doing this, we demonstrated the technology, and then let's see what happens. Well, this is not the purpose of the company. They have a clear purpose. They have to make business, and the business cases of the company, while focused on the Starship, but they are very similar, if not the very same, also for the other rockets, is that you have to be able to make money with these things. Basically, they are not your toys. So building the rocket with steel will make it easier when building. Also the materials, the works that you have to make on these materials will be easier. Also the overall industrial cycle from the raw material up to the final rocket will be shorter. So if you are planning to make something like 10 launches per year of the spacecraft, for example, just to give you an idea, you have also to be able to sustain these industrial cycles. So you need some material that you are capable of working quite relatively easily, and you need some material which is robust enough, and then so steel is one of the widest known material in the industry. You know very well the properties of this material, and you can perform quite accurate works on it. So basically it's the perfect compromise if you want a high performance material but also relatively ease of use in this kind of field. This is not uncommon in the aerospace field and the overall industry, not strictly related to aerospace. When you think about engineering, you are not making only science, but you should think that you are looking for suboptimal solution. What does it mean? Well, you are not looking for pure performance. For example, they are not optimizing the Starship to be the most powerful spacecraft, and this being the only point on the let's say wish list. They are not optimizing the spacecraft to be the lightest, they are not optimizing it to be the biggest, but they are trying to make all these ballots into the same list and optimizing the final rocket, which is the final solution to a common problem, to be as efficient, as cheap, as powerful, and also as big as possible, but considering all these things together. So how do you make this? Well, you need powerful engines, also efficient engines, and Starship and the Super Heavy booster use Raptor engines, which are powered by methane and liquid oxygen. So if you are still thinking about the Saturn V, you are probably thinking about RP1, which means rocket propellant 1, which was the propellant of the rocket of the Saturn V, which was used 60 years ago. It is still used, and means it basically is based on a compound of kerosene. But maybe you're wondering why they're using methane and liquid oxygen. I think that you already know the answer, and the answer is not that they are ecological, they are green, they are environmental friendly, because I'd like to underline this topic that making rocket is not the most environmental friendly activity that you can make, but I would prefer 100 times to build more rocket and have less polluting activities like industrial cycles and things like that in other sectors, because they are already developed. They can be efficient enough to be enough environmental friendly. Rockets are at the very edge, at the very beginning of their development. This is 100% normal. So well, the question is, if you want a video on SpaceX engine, just let me know in the comments. And maybe you know that they have just released another version of the Raptor engines, and well, just let me know if you want a video. I will try to create some content, also some articles on the website. Just let me know. But why are they using this mixture, this compound of propellants, which I remember they are liquid oxygen and also methane? Well, if you're looking at the video, you're probably easy in your answer, but I know that you already know the answer. Well, yes, they're using this compound because both of them that can be potentially produced on Mars, so reducing the need for a massive propellant transportation from Earth to that planet, and you can use in situ resources, so the natural resources that can be found on the red planet, to produce, for example, oxygen and also methane, and then use it to propel your rockets while you are on other planets. And basically, this is the core of the motivation, of the reasons behind the use of this propellant, this fuel and propellant combination, because they are probably not the most efficient, they are for sure not the most environmental friendly, but the main reason is that you can use the resources on Mars, on the Moon, on things like that to produce what you need, basically. So, but how many Raptor engines you have below Starship? So I'm still talking about the full configuration. Well, each Raptor engine employs a complex stage combustion design for improved efficiency. So if you consider that you have 33 Raptor engines below the Super Heavy booster, you may have an idea of how complex it can be, basically, because they have a very complex internal structure. I'm not only thinking about the fluid dynamics of the things, but also from a system point of view. A lot of systems contribute to the final function of the engine itself, and the efficiency is very high of these engines, and also the reliability of the engine itself and the overall vehicle is very high. You have to consider, probably you have seen some test flights, and you have seen that especially at the beginning, in the first flights, not all the 33 engines performed correctly. Even I don't remember the number of that test flight, but there was a couple of engines which were inoperative from the very beginning of the launch. Notwithstanding, the overall rocket performed a successful lift-off, so the thrust was far beyond the weight of the overall system. So the Starship is capable of lifting off from Earth without all the engines operative. So this is for sure a symptom of higher increased reliability and of redundancy of the systems, in particular the propellant systems on the rocket itself. So the other side of the coin, well, building Starship and operating it in particular is an incredibly complex and also expensive process. You have to think about what we were saying before, the materials that you use, the works that you have to perform on these materials, building all these engines, integrating the overall vehicle, the propellant, performing the launch, and then managing different missions. Well, these are all industrial process which can be made more efficient if you face them from let's say an engineering side, and you can also treat these now it is very much more possible with respect to 20-30 years ago to face the overall, let's say, problem of Starship from the industrial point of view. So you can look for the processes and zoom in and zoom out into the different processes and find the parameters which would make them more efficient, for example. But if you look at the big picture, it is still a very complex and expensive process, for sure. Well, SpaceX has invested billions of dollars into Starships and its development, and for sure it hasn't seen revenue so far, but well, this company is quite used to this because it developed the Falcon 9 rocket and then it was is almost bankrupt, and then ensured some contracts with NASA, and now it is the only American company which is capable of supplying the International Space Station, transporting a crew, American astronauts from Earth to the International Space Station and safely come back with the Dragon spacecraft, something that I have to say, as of the 12th of August 2024, Boeing hasn't demonstrated to be capable of yet, for sure, with the Starline spacecraft. We also talked about this in a different video a couple of weeks ago, so if you want, it is on the channel or on the Spotify podcast, you can listen or look at it for sure. Well, do you think that there is any future for the spacecraft? Well, I think so, but let's see the challenges it can face. Well, the project faces numerous technical hurdles, including mastering complex launch and landing procedures. I'm thinking about both landing the Super Heavy booster, which is something that SpaceX acquired a lot of technical skills about, but I am also thinking about the last test flights of the Starship, where the landing was quite complex at the beginning, and then it seems to have performed an almost successful splashdown in the Indian Ocean. But for sure it is again a splashdown, it is not a landing on land, and so still a lot of technical path has to be done, has to be run, for sure, but they are on a good way in my view, for sure. And I think that this is one of the most complex challenges that SpaceX has to face. The economical side, the fact that it can be incredibly expensive is not really a challenge on the horizon, because they can secure some contracts, and for sure the companies that will desire to launch with the spacecraft are not lucky enough, for sure. But the challenges are mainly technical as so far. So also some key points can be thought about. Also, achieving full reusability of both the Starship and the Super Heavy is a major goal, for sure. You maybe have heard about Elon Musk talking about the fact that 100 years ago you took a plane, but the cost of that plane were much higher, also because a lot less flights could be done on the very same plane with before changing its parts, its mechanical, and also rehauling the plane. Now you can perform a lot more flights without maintaining that plane, for example, and the same thing is to be done with rockets. There, for sure, achieving this major point with the Falcon rockets, the Dragon capsule, and all that side of the products of SpaceX. Starship is on the list to become the next one to be reusable, also from the spacecraft and also the booster point of view. But this is one of the biggest goals on the company, to make launches cheaper, and for sure this is at the very base of the business case of SpaceX Starship, for sure. Well, another point is that Starship represents an ambitious leap forward in space exploration technology. We mentioned the fact that you could use in a few years Starship to move point to point from between 2 points which are both on Earth, so you can lift off, for example, from the USA and perform a very little flight and land in Asia, for example, with very reduced times, so much faster than by airplane. But also you can use Starship to go on the Moon, on Mars, and also to perform deep space missions, both crewed and uncrewed. So this is let's say the final goal of the vehicle itself. The way they will reach this goal is being cheaper, being reusable, facing technical hurdles, but this is the final goal of the whole thing, for sure. And also the development is crucial for the future missions to the Moon and Mars. Well, I have to underline that for what it seems, what we know, but I think that we can also rely upon this information. Starship is the most advanced vehicle to perform this kind of mission, so bringing man back on the Moon and also on Mars, because SLS seems to be still and again behind schedule. So probably it is let's say the second vehicle behind Starship which will be capable of transporting men back on the Moon, for example. So I think that coming back on the Moon will be the enabler for further missions, crewed mission for sure. So I think that Starship is at the edge of this kind of space exploration, and I'd like to leave you with this thought, and maybe let me know what you think in the comment. Reach out to us on our social platforms and also our website. Let us know what you think about Starship. Maybe I've said something wrong, or something that you'd like me to go deeper into detail. Just let me know in the comments or wherever you want. I will read and also answer everyone to you. Thanks for watching. I love that you're still here watching the video, supporting us. It's completely free to be part of the club, so you can join on our website, give advices, let us know what you'd like to know, to think, and also to learn, because we are going to release a lot of content also under that point of view. Thanks again. See you in the next episode. Bye.